Hi everyone, today's lesson is going to be on properties of parallelograms. So a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So if I look at this figure to the right here, this top side is going to be parallel to the bottom side because those are opposites, and then my sides on the left and right are going to be parallel to each other as well, which if we remember means that even if these sides went on forever and ever and ever, they would never intersect. Now, parallelograms are going to have some special properties, so these are pretty important. You're going to see these properties over and over and over again. The first being that opposite sides of a parallelogram are also congruent. So these opposite sides here are going to be congruent to each other, and then the sides on the left and right are going to be congruent to each other as well. We also know information about the angles of a parallelogram. So opposite angles of a parallelogram are also congruent. So this angle here on that top left is going to be congruent to its opposite angle on the bottom right. So it's the angles that are across from each other. And then these two angles here are also going to be congruent to each other. And we also know information about the consecutive angles. So consecutive angles are angles that are next to each other. So if I called this angle here X, these angles Y are both consecutive to angle X because they're next to that angle instead of being across from, okay? I can call both of these angles Y because I know my opposite angles are congruent. So I can call this angle here X. And the property that we know about consecutive angles is that they are supplementary. So the measure of this angle X plus Y is going to equal 180 degrees. And then finally, we know that the diagonals bisect each other. So if I were to draw in a diagonal here, all right, I can draw in both diagonals. That means that this diagonal is going to bisect or cut that first diagonal in half. So this piece is going to be congruent to this piece, and then these two pieces are going to be congruent to each other. Be really careful. This does not mean that the diagonals are congruent. It's just their pieces of one diagonal are congruent to each other. All right, so let's talk about how to use these properties to solve for missing variables in a parallelogram. So if I look at my first problem, it tells me to determine which property of parallelograms is depicted and then to solve for the missing variable. So I'm talking about sides here, and it's giving me the measures of the sides. So I'm going to use information about my opposite sides being congruent, which means I can set this 3x plus 2 equal to 74 because they're congruent. So 3x plus 2 equals 74. If I wanted to solve for x, I'm going to subtract 2 from both sides and divide both sides by 3. So x is going to equal 24. And I forgot to put that property, but we used the opposite sides being congruent, and I'm just abbreviating there. If I look at number 2, I am given information about angles. So that measurement is inside the parallelogram, and it also has that degrees notation there. So that tells me I'm talking about angles, and these two angles are consecutive. They are not opposite, they are next to each other. So my consecutive angles are going to be supplementary. So I'm going to write that property down first. So consecutive angles are supplementary, which means I'm going to add them and set them equal to 180 degrees. So the first thing I want to do here is combine like terms. I can combine that 56 and -8. And I'm going to subtract 48 from both sides. And then divide both sides by 4. So x is going to equal 33. All right, looking at number 3, I have diagonals drawn in here. And it tells me that I have this 5x minus 3. I want to set this equal to one of these two segments. And if I go back and look, I know that the diagonals bisect each other, so the pieces of the diagonals are going to be congruent to each other. So I want to set that 5x minus 3 equal to 32. My property is diagonals. And I'm just going to abbreviate and write diagonals bisect. Well, I should write each other here. All right, we'll write that whole thing. Diagonals bisect each other, and I can set these equal to each other. So I add 3 to both sides. 5x equals 35. Divide both sides by 5, and x equals 7. I'm going to look at number 4. So again, here I'm looking at sides. I'm looking at opposite sides. So I see that I have 3 sides that are labeled, but the only 2 that are an opposite pair would be this 3x minus 5 and x plus 3. So those are the 2 I'm going to set equal to each other. Again, we have opposite sides congruent. And I have 3x minus 5 equals x plus 3. And I want to solve for x. Add 5 to both sides. 2x equals 8. And x equals 4 is my final answer. In this next problem, I see that I'm talking about angles, so this is inside my parallelogram. I have that degree notation there that helps me know I'm talking about angles. And I see that these angles are opposite. They are across from each other. So if I go back and I look at my properties, opposite angles are congruent, which means I can set those 2 measures equal to each other. So 5x equals 110. Divide both sides by 5. And x equals 22. Here I have opposite angles are congruent. And finally, with number 6, I see that I'm talking about diagonals, so I'm just going to write diagonals and abbreviate that quite a bit. But I know that the pieces are going to be congruent. So each piece of the diagonal is going to be congruent to each other. So if this side is 15, or this piece is 15, this piece has to be 15 as well. So 15 plus 15 is 30. And I can set that equal to the whole diagonal, which is 3x plus 3. All right, and again, solve for x. Divide both sides by 3, and x equals 9. Okay. Now, for the next set of problems, we want to find the measure of different segments or angles. So we are going to have to solve for x, but then we're going to have to go a little bit further and also solve for the measure that they want. So I'm not going to show every single step here. I'm not going to write the properties out just to save a little bit of space. All right, but it's the same procedure. So if I look at number 7, I'm given information here. All right, these 2 measurements are talking about my sides. These are opposite from each other, so I know my opposite sides are congruent. So 7x minus 5 equals 4x plus 13. Again, I'm not going to show every step, but when I subtract 4x from both sides, I'm going to get 3x minus 5 equals 13. Add 5 to both sides. And then divide both sides by 3, and I get x equals 6. All right, now I'm not done. I have to take that value of x equals 6 and substitute it in over here where I see x in the measure of AB. So AB is going to equal 7 times 6 minus 5, and if I simplify that, AB is 37. Okay. For number 8, I want to find the measure of angle JML. I look at the two angles that I'm given. All right, and before you try to set up any equation, you want to ask yourself, are these opposite angles or are these consecutive? Because these angles are next to each other, that tells me they're consecutive, and consecutive angles are supplementary. So we're going to set 5x minus 4 plus 11x plus 2 equal to 180 degrees. I'm going to clean up the left side of that equation, combine like terms, to get 16x minus 12 equals 180. Add 12 to both sides and divide both sides by 16. So I'm going to get x equals 12 as my answer. And now I can take that value of x equals 12 and substitute it in here for the measure of angle JML. So I have 5 times 12 minus 14. 60 minus 14 equals 46. So the measure of angle JML is 46 degrees. If I look at number 9, again, I'm talking about angles. I'm going to highlight those angles and ask myself, are these opposite or consecutive? Because these are opposite, I'm going to set them equal to each other because opposite angles are congruent. Subtract 7x from both sides, add 11 to both sides, and x equals 15. And then I can substitute that in to the measure of angle W. So that's 8 times 15 minus 11, which is 109 degrees. Okay. Finally, I have number 10 here, find the measure of angle, I'm sorry, not angle, but of segment SU. This one's a little bit trickier. So I always like to mark off my diagram with what I know, especially when I'm talking about diagonals. So if this piece is 3x plus 1, then this piece is also 3x plus 1, and it's going to be equal to that whole segment, 5x plus 9. So instead of writing 3x plus 1 plus 3x plus 1, all right, I'm going to write 2 times 3x plus 1 equals 5x plus 9. All right, this is just going to save me a little step with distributing. All right, you could have done 3x plus 1 plus 3x plus 1 and combine like terms, and you would get the same thing. I'm going to subtract 5x from both sides. So x plus 2 equals, whoops, that should be a 2. X plus 2 equals 9, and x equals 7. And I can take that value and substitute that in here. 5 times 7 plus 9 is 44. Okay. Now, I'm going to look at the next 3 questions. So these are all a little bit different. Number 11 can look a little bit overwhelming. We have this diagram here, and we need to find all of these missing angles or segments. So we're going to start with the segments first. I think that's a little bit easier. And what I'm going to do is, before I even look at the segments I need to find, I'm going to label what I know in this diagram. So it tells me that this segment WX is 18. So my opposite side also has to be 18. I know that XY is 14, so its opposite side must be 14. And then I look at my diagonals. If this piece of my diagonal is 9, this guy has to be 9. And if this piece is 13, this piece is also 13. All right, I'm going to draw in those little tick marks there as well. Okay. So let's look at the segments we needed to find, and hopefully we found most of them. So the first one is ZY, and I see that's already labeled as 18. So we're good there. Next, I need to find WZ, which I also found. So that's 14. XZ, all right, I know that XV is 13 and VZ is 13, so I can add those together, and XZ is going to be 26. And then VY is labeled already as 9. Okay, so I found all my segments that I needed to, and now I'm going to do the angles. So I'm going to erase everything that I just did there, just so I'm starting with a clean slate. And we're going to go through these angles piece by piece. So the first angle that I want to find is angle WXZ. Okay, now let me label that here. Okay, I know the angle next to it is 41, but that doesn't really help me. I know this angle down here is 60, but that's not the whole angle. So what we're going to do is go back to the definition of a parallelogram. And we know that a parallelogram has two sides, or has opposite sides that are parallel. So I'm actually going to highlight here my opposite sides and one of those diagonals. All right, if I just focus on those blue lines here, all right, and I know that these sides are parallel, all right, this looks like our parallel lines and transversals when we learned about all those different types of angle relationships. And I know this angle down here is 32, so this angle here is also going to be 32 because those are alternate interior angles. So that's where the definition of a parallelogram and your opposite sides being parallel is going to come in place. It's actually going to be used when we're solving for angles instead of sides. So I know that WXZ is 32 degrees because I have a pair of alternate interior angles. Okay. Next, I want to find angle ZYX, and I am going to erase those lines that I drew. Okay, I'm going to keep that 32 there because I might need that. So angle ZYX is going to be this whole angle here. I know this piece is 60, but I need to find this missing piece here. Now, I'm not going to try to find alternate interior angles again, but if I look up here, I knew this angle was 32. So that means this whole angle WXY is going to be 73 degrees. All right, that whole angle there is 73. So if this angle is 73, this whole angle here is going to be supplementary. So I could take 180 degrees and subtract 73, and I'm going to get 107 degrees. Okay, so again, I added up my two angles here. So angle WXY was 73 degrees. And I know that whole angle has to be supplementary with that whole angle ZYX that I'm trying to find. Okay. Next, I want to find angle ZVY. Okay, so this one is a little tricky. All right, I'm going to call that, well, let's not call that X. I'll call that a little a. I'm trying to find this angle here. Okay, and I'm going to use my angle ZYX to kind of help me out. So I know this whole angle was 107. I just found that. So I know that if I subtract 60 from that, that's going to give me this other piece here. So this other piece here is going to be 47 degrees because I have 107 minus 47 or minus 60, which is 47. Then I can look at this triangle here. Okay, I know the sum of a triangle has to equal 180 degrees. So 180 degrees minus 47. So 180 minus 47 minus 32 is going to equal 101 degrees, which is my angle over there. Okay. The next angle I want to find is ZWX. All right, so that's the whole angle here. All right, this angle ZWX is going to be congruent to ZWX that I already, or I'm sorry, ZYX that I already found. So if this whole angle was 107, that angle is going to be 107 degrees as well. And finally, the last angle that I want to find is WZY. Okay. And again, I actually already know that angle. All right. Because when I added this angle here, this 32 and 41, that whole angle WXY was 73 degrees. So WZY is also going to be 73 degrees. Okay, that one's definitely a tough one. You're using all of those different properties. So you really have to remember all of our angle relationships, the triangle sum theorem, all of that stuff comes to play in that problem. Number 12 is giving us this parallelogram ABCD, and we want to circle all the statements below that must be true. So we're just going to look at each one of these and determine if they are true. So AB is congruent to CD. Yes, we know that's true because they're opposite sides. BAC, angle BAC here, is congruent to BCA. All right, that's actually not true. All right, I don't know that these two angles have any special relationship. They're not alternate interior angles. All right, so we can't circle that one. Segment AE is congruent to ED. So segment AE here is congruent to ED. I don't know that to be true. All right, remember when you are looking at your diagonals, all right, the pieces are congruent, but they're not congruent to each other. So I don't know that AE is congruent to ED. Next, I have DAB. So that whole angle DAB is congruent to DCB. That is true. Those are opposite angles. So those must be congruent. My next one is AE is congruent to EC. Marked that off as being congruent, right? Because my diagonals bisect each other. Angle BAC, so that's this angle here that I'm marking in red, is congruent to DAC. I don't know that to be true, and I can even see in this example here that that diagonal does not bisect my angle. So this angle was 32 degrees and this one was 41. So it's a perfect example. I don't know that those angles have to be congruent. I have side AB is congruent to CD. That has to be true. That's my definition of a parallelogram. Opposite sides are parallel. Segment AC, that's one of my diagonals, is congruent to BD. Do not know that diagonals are congruent. We just know that they bisect each other, so I can't circle that one. And then finally, I have angle ADB. So ADB right here is congruent to DBC. Okay, that I do know is true. So again, if I draw in my parallel lines and a transversal, I see that those are alternate interior angles, so those must be congruent. All right, last question, number 13. It says quadrilateral LMNP is a parallelogram with coordinates -4, 4. That's point L. M is 4, 5. And point N is 7, 0. Okay, we want to find the coordinates of what point P would be. All right, so if this is a parallelogram, I know my opposite sides are parallel. So I'm going to look at the slope of what, you know what, I'm going to do this with a straight line here. There we go. That's a little bit nicer. Okay, so I'm going to look at the slope of LM. So the slope of this segment LM, I'm going up 1. So the slope of LM, I'm going up 1 and then over 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I want to find a point that would make this a parallelogram, I'm going to do the opposite to point N. I'm going to try to find a point that when I plot it, it gives me that same slope of 1 over 8. So I'm going to go in the opposite direction from N. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 to the left and 1 down. All right, and if I check that point is -1, -1. Okay, so if I draw in that line there, okay, I know these two lines would be parallel, and you can just double check to make sure that the other segments would the other sides would also be parallel. All right, if that was P, and I look, LP would be down 1, 2, 3, 4, 5. So the slope of LP, I'm going down 5 and then over 3. And the slope of MN, if I want to check, is down 1, 2, 3, 4, 5 over 3. All right, so this point here, -1, -1, is going to make that quadrilateral a parallelogram. And that's it. If you have any questions, you can drop them in the comments below. Have a good day.